Once again, welcome to Till DevOps. Yesterday we had a session on course content. I have briefed on each tool and what are the things that we cover on this course and what are the real-time projects, how a DevOps engineer should be, and all. Today in this session, we will discuss more on history of DevOps and understand the basic terminology of DevOps, what a DevOps engineer do on daily basis, and what sort of roles and responsibilities does he have. Okay, he or she have when you get an opportunity, what kind of roles you will be playing in as a team member. Okay, so let's not wait. Let's start the session. So history of DevOps, history and evolution of DevOps. Even before DevOps, what were there? Okay, so that is where things get interesting because all this DevOps is doing all the rocket sciences that people think in organization. Like we handle the infrastructure, we handle the deployment, CI/CDs, automations. We do all this work in an automated way with without any manual intervention as such. We will talk about all those things, but then what were there before DevOps came into picture? So that we have to understand. So DevOps is a combination of development and operations. Okay, so even before. Okay, one second. Wait. Okay, so development and operations. That is what terminology says. But there is a in-depth meaning of it. It is not a tool. DevOps is not a tool. It's a terminology. It's a process. It's a methodology that we follow. Okay, it is a combination of a brief set of instructions, process, technical tools, uh, and other ecosystems that we talk about in this session. Okay, so before DevOps, we have the development and operations. Coming back to the previous generations or in the early stages of software development life cycle, people used to work on different entities like development and operations. Operations used to take care. One second. Maybe I have to assign someone as a admin to accept those requests every now and then. I'm getting sorry for that. So the five stages of DevOps. Even before that, we were talking about development and operations, where developers used to work on their activities, and team used to work on environments where they take care of hosting the application, deploying the application. So, what sort of differences does it make to bring out this DevOps as a combined technology or a methodology? So the reason why it came was because due to the differences and the lack of collaboration between the development and operations teams and lack of platform issues, not standardizing the platform, and there are other approval issues. There are a lot of things that made sure that DevOps came into picture in the early stages of 2000. So what sort of differences there were there at the time was like we had development team does some development, and they say that development code is working in their servers or in their local laptops or in development environment, but when it is deployed on staging or production it is not working. So the operations team come back and blame on developers, and developers come back and show that they have done something wrong in their environment, so it is not working because it is working in our environment. So the reason could be anything. It could be the different issue with the operations team, or it could be issue with the development team. There could be any issue, but there is a lack of collaboration, which is making the deliverables delayed or they are reaching out of the deadlines. So that is where these product management teams came with a new terminologies we called as DevOps. Okay, so evolution of DevOps, how it has been evolved. So earlier, in earlier stages, it was meant. See, I started working in 2016 or 2017 around. So when I joined in the company, it was like very early stages. We used to take care of only CI/CDs, where I used to see only SVN, Git, and Maven, SonarQube, Nexus. So this was the DevOps at that point of time, because we were only handling CI/CD, continuous integration and continuous delivery, and we used to do the deployment with the Jenkins tool itself with some automations, shell script and Python scripts and all. Okay, that was the earliest stage of DevOps. Okay, so to set that set of tools, we have to standardize that. So to make sure that any CI/CD is working, there is prerequisites to set up any pipeline. Okay, like we have to set the branching strategies, we have to set the guidelines for development team, we have to set the environments without any changes. The variability of environment should be not there. So we used to set certain set of guidelines, and we have to pick the tools based on the requirements of the developers. Okay, so we as a DevOps engineer, we our stakeholders are our clients are developers. Most of the times it is developers. If your team is working dedicatedly for QA, so then it will be QA. And as a consolidated DevOps team in any organization or in any business unit or in any project, we serve multiple teams. Okay, we are the solo point of contact for multiple teams for any environment issues, for any tool related issue, or any build issue, or any deployment issue, or any resources related issues. Okay, we will talk about this chunk of pieces in bits and pieces in upcoming uh, uh, slides. Okay, so in this process, what we used to do is we used to first set the guidelines. Like developers should definitely follow our guidelines, because all our pipelines will be based on that pipelines only. Okay, so those pipelines, to make sure that all these pipelines are being followed in a standard format, we have to have a basic set of tools. It means like a basic set of tools. Like it could be SVN for storing your code, and we set those strategy, branching strategy, where developers will push their changes to a feature branch, and there is a development branch that is common for all the developers. Every developer should create their own feature branch. I'll talk about these things little later when I'll talk about source code management. I'm just giving some glimpse to understand what sort of technology stack that we have to define. Okay, so let's suppose now I have got a requirement. Yeah. So let's say I have got a requirement saying like I want to build an application which is something like book my show, or anything that you want to talk about. Let's say book my show. Now to create a book my show for a book my show app, what are the basic things? Let's say we have to talk about movies, not any other comedy shows or nothing else. So to create a book my show app, what are the basic things that we need? So requirement gathering will be there. There is a product team where all the product team, development team, multiple people sit together and they'll create a requirements. So based on the requirement, they'll create a technology stack, which means what language they have to use, what is the front end, what is the back end, what sort of databases that they have to work on, what kind of data they will get in, what is the future of this particular application if it kicks in, and then what sort of maintenance does it require. Okay, so all these things will get decided, and then they will come up with a plan for developing the project. So when they start development of the project, they'll come to the DevOps engineer and they will tell that, hey, we are doing this and our tech stack is this. So give us a proper set of pipelines where we have to do this CI/CD, which means build and release, and then we have to do the deployments on multiple environments, and we need these environments like this set of virtual machines they need, this set of databases they need, and these many environments. Let's say like they need 5 servers in development environment, 10 servers in staging environment, and 15 servers in production environment. Or they'll come if they don't have any clarity on that, they will give their requirement and they will tell that they are targeting these many customers at first level of first level of release. Like they have, let's say there are 10,000 customers in the first level of release. To serve the 10,000 customers and to see the load of the to understand the application and see the load of the 10,000 customers, we as a DevOps engineer or infrastructure architect, there will be an architect sitting in front of us, or we as a DevOps engineer who involves on DevOps as well as infrastructure part of it, we will give suggestions. Okay, it is at very initial stages where we will give some suggestions to them that you can go with 8 GB of RAM, we can go with 1 TB of 1 TB of database, and we have this 8 CPU cores. We will tell them these are the primary requirements. Okay, so when you say those kind of primary requirements, they will start their development. We will start setting up the pipelines, and once the first code base is there, we will give the branching strategies, and we will say that hey guys, you have to follow the branching strategies, and we will set up the pipelines according to that. Let's say if a development branch is there, we will create a snapshot artifact. If it is a release branch, we will create a release artifact. So don't get confused with the terminologies. Again, I will be telling each of these names when we will talk about that particular tool during the build and release process. Okay. Just understand the concept, how it has been evolved. Okay, so then we will set up these guidelines, and then we will set up the deployment strategies. It could be canary deployment, or it could be rollout deployment, or it could be blue-green deployment. We have a lot of deployment methodologies. We will decide on that, and then we will give a strategy on that as well. Once that is done, we will give a strategy of approval. So once what sort of verification does a QA team means like testing team should do to approve it and make it move it to the staging to production. So there should be some approval process. So that set of approval process also we will be setting up, and it is QA team's headache how they will manage the testing, sanity testing, performance testing, penetration testing, security testing. There are a lot of testings that they will do, including the functionalities, and they will come up with a like a go to production. So they'll give that, and that is where the service owner or the application owner will give approval to move it to production, on top view. So in this scenario, the normalization of technology we have discussed, that is the first stage. Second stage is standardize and reduce the variability. Variability here in this sense, like our CI/CD system or build and release system, our infrastructure, and our monitoring system. Even though if there is any sudden changes in the code or in the application, our entire CI/CD should not, shake with these changes. Means our CI/CD should withstand, our infrastructure should withstand with all these sudden changes. So we have to make a robust system which will withstand with all these changes or upcoming loads. We have to give high availability things. So with very minimal changes. Okay. So that reducing the variability is nothing but change. Means like very less changes should be instigated to the infrastructure so that it doesn't affect any of the end users. So when recently when the Salar or Donkey released, at the time you see Book My Show app crashed in the mobiles. You were able to access it from the website, but then on mobile applications it has been crashed because a lot of people at a time hit that Book My Show and it was not able to scale, or it took some time to scale the application. In between, you see that lag between your request and your response time. So that is where you understand the concept of what is happening behind the scenes. If you see the government applications, when we used to get the 10th class result, we used to see that server is timing out or server is not available, or we used to not get the response. All this is because of the infrastructure issues. They used to have less infrastructure. On one particular day when the results are released, all the students will hit that server and the server will get crashed. Again, they have to increase the resources and again make it available. That's a different story. We will talk about that. But then that is where our DevOps team come into rescue, where we will plan the high availability concept. Okay, we will plan high availability, saying that even though if right now if there is 10,000 customers, suddenly if the spike is increased like 20,000 customers, we as a DevOps engineer should ensure that it should automatically scale the instances. Even the Hotstar, the Prime, or if you see any of those, it can withstand the live streaming when the cricket is going on. So that is where robot system comes into picture, and we are the rescuers for those type of robust architectures. Okay, so that is where we do standardize and reduce the variability. Expanding the DevOps practices here is nothing but earlier it was DevOps. Now which used to involve on continuous integration, continuous delivery, continuous deployment, continuous testing, continuous feedback, continuous monitoring. Now there is a new concept called DevSecOps, where security is involved. We'll talk about that. Security is also involved. Now later part of time they have started including the infrastructure. Then there is the containerization concepts where Docker and Kubernetes came into picture. Like that, the DevOps practices have been evolving over a period of time with the tools itself. Okay, so there are a lot of open source tools, there are a lot of paid tools. We can see a lot of tools, but if you trust me, if you understand the concept of Linux, if you understand the concept of one tool, any one tool, like Maven, SonarQube, Nexus, Jenkins, rest all the tools will be very similar. The startup means like starting the application, starting the tool, restarting the tool, or managing the tool, upgrading the tool, all the administration of these tools. It will be almost similar. Okay, it is not that complex. It is just that integration process and the functionality process is what you have to understand. Okay, that is where I'll be dealing the technicalities of integration, functionality, and the options that we get from each tool where we use on daily basis comes into picture. I'll be dealing all those things. Later part of time, automation of infrastructure came into picture. Now, earlier the automation, how it used to happen is like if you want to procure your service, a lot of people, if you are working on the companies or organizations, you should be seeing that you have to procure, if you want to procure a virtual machine or if you want to have access to any virtual machine, you have to raise a IT ticket, IT service ticket, which is a lot more difficult process. You have to raise the request, you have to get it approval, and IT team will have to take the ticket. They have to again they will be having SLAs, standard SLA procedures. I forgot the expansion. Sorry, I'll be telling you. There will be standard SLAs for means deadlines. They will be working on the deadlines. Again, if it is urgent and you have to raise the P1 ticket and we have to provide the justification, a lot of things will be there and it takes time. And it's a manual process. Even though the IT team is also will be doing almost manual process from the UI or from manual side of it. So DevOps came into picture, and there is cloud that has changed the entire infrastructure provisioning. And in the cloud itself, we are using infrastructure as a code, which is an automated process of provisioning infrastructure. Means we are writing a code to provision infrastructure, to provision EC2 machine, to provision virtual machines, to provision databases, to provision storages. We write the code, and that code will provision infrastructure on the cloud. Okay, so that is where automation of infrastructure came into picture, where within a span of minutes or seconds, you will get your infrastructure ready with the pipelines. Okay, that is the fourth stage, and the fifth stage is self-service capability. What so in this entire four stages, we have seen how the automation, how the CI/CDs, how these DevOps practices has evolved. Now this is the fifth stage where the architecture will be self reliable, where it will automatically uh, uh, automatically scale the instances, automatically verify the not working instances like virtual machine. If any virtual machine is not working, or if any virtual machine is having an issue to serve the load, serve the customer, then it will automatically take that take that particular server out of the pool and create a new server. Means self-healing capacity. It is what we call it as self-healing capacity. So we have created a robust systems in the current infrastructure where if anything goes wrong, it comes in the Kubernetes concepts, but then you can also relate it to the virtual machines as well. So if it finds any virtual machine is not working or not able to provide or serve the request, which we check the health check of each virtual machine. If that is not healthy, our automations or our cloud environment is capable of removing that and creating a machine that automatically creates and fits into the pool. Means it will go inside the pool. So that is where self-serving capabilities have been evolved. Okay, so I'm not exaggerating. I'm currently working on this level of technology, and it is more fun when you understand the concepts of all these pod scaling, virtual pod scaling, vertical pod scaling, horizontal pod scalings in Kubernetes. I'm talking all those concepts. Again, we will be talking in detail of what those things are. It is very fun and very interesting concepts. Okay, that is what the history and evolution of the uh, DevOps came into picture. Right now, we are in the self service capabilities, and there will be sixth stage where no operations comes into picture. Right now, we are using DevOps. The next stage is no ops, no operations, where we will be creating a automation, or we call it as robots, bots. We call it as bots. Bots will take care of these things. We don't manually intervene. During nights or any daytimes or any peak hours, if there is something is going wrong, or if it is a repetitive issue and it is not, we cannot provide any particular permanent solution, then we will cover these particular things into like restarting, automatic restarting. All those are already there, but then there are certain use cases where you cannot even provide a permanent solution. In such use cases, we will, whatever we do as a manual work, we will do that. We will write it in Python automation and we will give it to a bot. Bot will apply that whenever it observes that particular issue, and it will automatically resolve that issue. If it is unable to resolve issue, then we will get a notification through PagerDuty or notification system or through email. Okay, that will be like very next level where we use multiple bots, Rasa bots. We have a lot of bots that is going to take care of the entire things. But again, you don't think that DevOps will go off if no ops is involved. All those no, if we want to implement no ops, again DevOps engineer should be there to maintain those no ops. Again, DevOps engineer should be there. Okay, that concept is there, and that is the next level of stage 5. We'll be talking that if at all I get more, I have got more information on that. If time permits, I'll add that as well in upcoming sessions. Okay, so first understand DevOps and then we'll see what MoOps is. So if you have any questions, do let me know. Please stop me, and you can ask questions in the middle itself. No objections on that. You don't need to wait till the end of the session. You can stop me there and you can ask me any questions that you have. Okay, so next thing is, what areas does DevOps cover? So all these stages I have covered most of the things, but then I wanted to give a brief idea of what kind of roles and responsibilities does a DevOps engineer do on day-to-day activities. That is the main motto of this particular session. Okay, so the thing is, as a DevOps engineer, right, you have to understand your roles and responsibilities. Even before you start your journey towards DevOps, first understand DevOps. What kind of roles and responsibilities does a DevOps engineer do? Day-to-day activities of a DevOps engineer, and then
Kalyan,
yeah, yes,
stopping here.
yep,
Actually, I want to know what comes under pipelines and what comes under branches.
okay. See, that is like you are going in depth. If I start talking about it, it will take another 2 sessions to complete. But then again, on top view, branching strategies is something related to the source code management. Okay, we have a Git as a code repository. We will store all the code, right? There are if there are 100 developers, right? If let's suppose each developer write 10 lines of code and you multiply with 100 developers, you got like 1000 or 10,000 lines. You have to store all these 10,000 lines somewhere, right? That somewhere is nothing but GitHub, which we call it as source code management. Source code management, the plain application code. Okay, that particular code is stored in GitHub. So in GitHub, to make sure that our pipelines are working fine, means we to set up a pipeline, we will give the branching strategies like development branch, release branch, QA branch, um, or hotfix branch, bug fix branch, feature branch, master branch. We have multiple branches. These things will be covered in the GitHub session. Coming to the second part of your question is pipelines. What is a pipeline? Pipeline, on a nutshell, it's an automated process or automated task that we create step by step to complete any task. It could be built, it could be release, it could be deployment. Okay, so we take the code from the GitHub, we build the code, we create an artifact, we create a Docker image, put it in the uh, Nexus or Docker Hub registry. Okay, again, these tools are different tools. I'll be talking about them in the upcoming sessions. But on a nutshell, to your answer, that is what a pipeline looks like. It is not about only that. There are a couple of freestyle pipelines where we actually do some automation stuff to support the other pipelines. That is a separate concept. I'll be talking about that in detail when we talk about Jenkins or CI/CDs. Okay,
Got
so
it. Thanks.
yeah, thanks. Now, coming to what areas does a DevOps engineer cover or a DevOps cover? So, like I said, build and releases where we so once the developer pushes his code to the GitHub, his work is done. So that is where our work starts. We take the code, we build the code, we create an executable file or a binary or an artifact, and we will publish it somewhere or we will store it. Publish in the sense store it somewhere for future references or for a dependency management. Like if there is a microservice based architecture, if I have 5 services, if second service is dependent on first, third service is dependent on second, if there is like dependency architecture, first service will have some code, you build that code, you create an artifact one and put it in the storage, which could be Nexus JFrog. Second service you build it, you create artifact 2, you put it in the this Nexus. Then third service is there, third service is dependent on first and 2, so it will pick those first and 2 dependencies from the Nexus and use it and again create a third artifact, put it in Nexus. Fourth application is there, that code is being built, I'll create a fourth artifact by using first, second and third and I'll put it in the Nexus like this. So two use cases for artifact management. One is to store the artifact, second is to manage the dependencies. It is not always the existing the dependencies that is going to build. We will also get some few dependencies from the internet and put it. Again, there is a process for it and I'll explain you during that time. Okay, so that is what CI/CD is, continuous integration and continuous delivery, which only handles the delivery process, not the deployment. In the next session, I'll cover what is delivery here. Okay, that's an interview question. Continuous integration, you can tell. Continuous delivery, you can tell. But what is the difference between continuous delivery and continuous deployment? People will ask that. Definitely, it's an interview question. Okay, so this CI/CD build engineer or build and release engineer, we can call it as, or CI/CD engineer we call it as. He will manage the build and releases of the team. Okay, this is one area. So there is a deployment area. So once this is done, deployment area will be there. Then there is a QA. Let's suppose you have deployed in the staging environment. Now that is a QA team coming to picture where there will be multiple pipelines that runs for testing team. Okay, let's suppose there are Selenium scripts. Okay, QA functional testing. Selenium script for Java application. So they will they here is nothing but QA team. QA team will write those Selenium scripts and put it in some GitHub repository. We as a DevOps engineer take that scripts, run it on the application or staging environment against that application against that application which is running in the which is deployed in the staging environment. So that scripts and all will be handled by them. Our job is to take the code and use the commands. The developers will provide the commands, or we can also figure it out from the Google or from the internet or from the standard SOP documents. We will run that. We'll give that command and trigger those scripts. That once you trigger the scripts, that scripts will hit the application that is running inside the staging environment, and it will give some output. If the job is successful, we will get an approval for putting it. We are deploying it in the production. If job is failed, then developers again should rework on the same code. Okay, so that kind of pipelines we will create. Data pipelines is something that deals with the big data, where let's suppose you have some raw data. Okay, let's say you have some 10 devices, something related to network devices, let's say mobile applications. You are testing that mobile applications, or you say like devices here in the remote, let's say mobiles. You have 10 mobiles. Sorry, let's say you have 10 devices which are mobiles, and each mobile is generating some thousands of logs. Okay, now as a data engineer, big data engineer, what does he do is he will collect using telemetry. Again, don't get confused with the terminology, it's all hypothetical things. You don't need to worry about it. Let's say there is some agents running inside mobile agent. Okay, some agent, software agent. So what that agent is doing, it is taking those data and putting it in our environment. It is transferring it to our let's say some object storage environment, or some any hard disk. Let's say one hard disk. Now all this raw data is kept in the hard disk. Now what does data engineer do? On a high level, data engineer will take the data logs, what all the logs that has been generated, and he will process the data. Means he will trim the data. Like raw data is huge, so they will be using some patterns, some mechanisms, some algorithms. Means they here is nothing but data engineers. They will have some algorithms which is going to process the data. Means they will trim the data to processed data. We call it as processed data, and put it somewhere in one of the object-based storage, or in another hard disk. Let's say another hard disk. Now there will be this process, this taking the, transferring the data, loading the data, and processing the data, and putting it in the another source, process, destination. So all these things can be handled through big data data pipelines. That entire automation, as a DevOps engineer, we will be taking care. That is also one scenario where DevOps engineer will work with data engineers or data science engineers to handle their automations. If they are doing it manually, we will automate them using pipelines. So that is also one scenario where DevOps comes into rescue. Okay, that is about these four. And there is a concept called infrastructure provision and maintenance, which means we will provision infrastructure or environments for like development environment, staging environment, production environment, which is on the cloud. It could be public or it could be private. Cloud here in AWS, Azure, Google Cloud, or any other private clouds as well. Cloud views we do have. Okay, so that provisioning of infrastructure and maintaining them, like patch management and all, we will be handling it as a DevOps engineer. That is also one area which we will be covering. The other very important thing is containerization of applications. What does containerization of application mean here? So earlier we used to deploy the applications on virtual machines, or the proper on-premises machines like laptops or servers or whatever you name it. So when this cloud came into picture, and when Dockers, Kubernetes came into picture, that is where the downsizing of applications have been started. Downsizing means if it is a monolithic application, monolithic is nothing but multiple small applications combined together as a big application. Let's say if you have a Paytm has a lot of options. You have a option to book cinema tickets. You have option to pay. You have option to do banking related stuff. You have options to check the credit score. You have options to create a apply for a credit card or pay amount for a credit card. Let's say there are multiple features. Okay, so if it is a monolithic application, all these features will be coupled. Okay, coupled means they will be tightly coupled in one single large application. So if you want to deploy or if you want to containerize this big application, then it will be a huge task. And again, it doesn't make any sense if you try to containerize such big applications. It doesn't make any sense. There won't be much difference. So that is where microservice based architectures came into picture. These monolithic applications have been decoupled. Means like book my I mean the option or the feature that we get for booking and tickets, paying the amount for credit card, checking the CIBIL score, they have been decoupled and they have created a dependency. Microservice based architecture is nothing but all the chain linkings. Like this application is dependent on that, that application is dependent on this, and everything can be decoupled, again coupled. Okay, means they will be having a dependency, but then you can always shut down one and manage the other one. So let's say if Paytm is running, and if you have a monolithic architecture, if one feature like let's say this booking cinema tickets feature has been overloaded, then entire your application is have a chance of getting crashed. That is where microservice comes into rescue, where everything will be decoupled and the dependency service discovery dependency architecture will be created. And then what happens is, let's say that particular feature is going down, but entire application will not go down. Only that particular feature will come out of that option. The other will run as usual. So that is where monolithic architecture came into picture. Once monolithic architecture came into picture, we have started containerizing the applications. Where if you say monolithic application is one single big application, microservice, when you divide that particular application, it will be like tens and hundreds of microservices will be running. You cannot provide one entire via virtual machine for the small applications, for the small features. So that is where Docker come into picture, where each particular small microservice application will have a container. Container is a lightweight operating system. Okay, we'll be talking about that in detail, but then you just understand Docker is a lightweight operating system. Means in if you say laptop, if you want to start a laptop or boot a laptop, it will take a lot of time, right? If you want to boot, it will take 15 to 20 minutes. Or if you want to start a virtual machine, or if you want to restart your laptop, how much time it will take? You have to do the restart. It should boot. It should come up. All the applications, basic booting applications should come up, and then your application will run. So it takes a lot of time, at least 1 to 2 minutes or 3 minutes. Sometimes it is, if it is a big application, it takes 5 minutes. But in microservice based architecture and using the Docker as a uh, uh, containerized tool, it will be like wrapped within seconds. You can create a container. Means container is here nothing but lightweight operating system. It will be using the underlying host application resources, machine resources, but then it is very rapid. It will have, we can customize that OS, that particular lightweight operating system that we call. We can customize it. We can remove the unwanted things. We can add only what we want for our application, and we can make it lightweight. Okay, so those things we will containerize. And if you have like hundreds of microservice applications, Docker cannot help you to manage them in a better way or standard best practices. You have to rely on container orchestration tool, where Kubernetes or Docker Swarm come into picture. Okay, so we will be how to create such applications, how to deploy them, what tools help you to deploy on the Kubernetes, what is Kubernetes, everything we will be discussing. Okay, post that there is a so as a DevOps engineer we will cover that, and there is a dedicated positions for Kubernetes itself, Kubernetes alone with monitoring. Okay, so I'll talk about that also. Now there is monitoring and observability, or observability. What that is, like all these things that we have created needs infrastructure, right? To run a Jenkins machine, to run a Jenkins tool, to run a Nexus tool, to run a SonarQube, to run your applications, you need an infrastructure, and you never know what machine comes up and what machine goes wrong. Okay, so you have to keep an eye on all the machines, and you cannot, as a human being, you cannot keep an eye on that every day. So we will be depending on monitoring tools. We have monitoring tools, lot of monitoring tools: Prometheus, Grafana, Zabbix. We have Victoriometrics. We have a lot of things. Cloud in the AWS side, we have CloudWatch. So all these tools, what it will do, it will monitor two different things. One is application monitoring, the other one is infrastructure monitoring. So we'll be covering both. As a DevOps engineer, we'll be handling that as well in the SRE concepts. Okay, these are the main areas that we cover, and there is one more concept called security that I'll be covering in the next slide. Okay, so what kind of job titles do we have? Okay, so if you open Naukri and search for a DevOps position, you get very similar positions. Means like you can search with any of these names. Okay, you will get a positions there. Some big companies will segregate. I mean, big product based MNCs are will have a standard designations or standard job titles: DevOps engineer, senior DevOps engineer, or cloud engineer, like that. But if you see some product based companies or big product based companies, they'll have a dedicated position like build engineer, deployment engineer. Then you have this platform engineer, configuration management engineer, operations engineer, SRE, site reliability engineer, systems administrator, cloud engineer. We have a lot of things. Let me go one by one. Okay. So if you get a DevOps engineer role, so DevOps engineer role, again, if you see these things, right? If you observe any job requirements, it doesn't say that we only work on this particular tool, or only we need this particular tool. They will cover everything. Okay, so they'll say, so once you get a chance, okay, being myself, I work for multiple product based on one of the MNCs. So in my past experience, I have seen, once I get an opportunity, I'll be working on 2 to 3 tools or 4 tools maximum. Okay, on daily basis, on a long term basis. But if you see interview patterns, they will ask beyond that also. You have this, you have that, and they'll keep everything in the job description. But again, you have to understand the role very well. You have to see the job description, read the job description, see what matches for you, what doesn't match. And if your job matching percentage is more than 50%, then you will be a good fit. That is how HR, human resources, will pick your resume and they'll map it. Okay, so few things you see, nobody can be a good fit. Okay, it is all the best match. Take that, whatever you know, you just have to prove that, and then the rest of the things you will get it on the daily basis. Okay, so as a DevOps engineer, we will be handling, like I said, CI/CD, deployment software systems, which means setting up the CI/CDs, pipelines and stuff. Okay, build and release engineer, he will be taking care of, like I said, CI/CDs, release management. Release management is a big concept again altogether. Build is separate concept. Release management is altogether a big concept. And that entire setting up the thing and releasing a software, releasing a version of the software for the end user or for the customer, that is itself is a big thing. Okay, so that is one separate role. Deployment engineer, he will, so those who get a deployment engineer role, he will be managing the deployments on development environment, staging environment, production environment, and if there is any other environments available. So that is a deployment engineer do. He will deploy the applications on the environments. What does a CI/CD engineer do? CI/CD engineer, DevOps engineer, build and release engineer are almost same. There's the terminology differences. So DevOps engineer will actually design CI/CD and deployment. He will build engineer will manage the existing things, and if there is any updates required for the existing thing, he will be managing as a build and release engineer. CI/CD engineer is someone who will implement the new implement, maintain, and also he will manage the tools as well, tools orchestration, which means if there is any tools that needs to be upgraded like Nexus, SonarCube, Jenkins, um, uh, and if there is any Docker versions needs to be upgraded. So all these things will be handled by CI/CD engineer, or you can say DevOps engineer also will do that. So that is a part and parcel of our daily routines. So on daily basis, we work on build and release issues, like if there is any job failures, automation failures, or if there is any additional automations required, we will be working. That is our daily task. On top of it, every now and then we have to check the versions of the tools, and we have to plan for the upgrade of the tools as well, like Nexus, SonarCube, Jenkins. So we'll be doing that also as a DevOps engineer. Now coming to platform engineer itself says it is more it more deals with the infrastructure part of it, infrastructure provisioning, maintenance, patch management, and all. So
So,
hello,
sorry to disturb. Your voice is breaking. Is it only for me or everyone?
can someone confirm if my voice is breaking?
No.
No.
Yeah, your voice is breaking. Is it only for me or everyone?
It's clear.
Is it me? Is it only for
It is fine for us.
No, Kalyan, it is clear.
Okay,
Yeah, it's
I
fine
think
for us.
I think you have to check your network.
Yeah. Okay.
Yeah, sure. Thank you. Okay, so coming back to our slides. Right. So platform engineer is someone who designs. See, architecture. See, we won't design anything. It's an architect who will do that, or a senior leads or lead engineer, or a level of senior leads or above architect. They will be designing that. We are the implementers. Okay, they will give us the design, we will implement. It is not alone you do it, it is always a team of group of team that does, by dividing the tasks together. Okay, so it is not a rocket science, it is not that difficult, and no one is doing it from the scratch, it's already there. Every company has its DevOps already evolved over a period of time. It is just that maintenance is required, so we are there. Okay, so that is where positions comes in. We have to maintain every now and then, we have to manage the dependencies, we have to manage the security, we have to manage the tools upgrade process, disaster recoveries, we have to do lot of stuff, so we are available. It is not that you do it from the scratch. Okay, but then you have to take where it is there, means when you join a project, to take from where that is available to the next level, you have to understand what is there in that. So to understand that, you have to know the basics. So this is what it is going to cover. Our course will cover all the functionalities, basics, and the project level automations, CI/CDs, infrastructures, Terraform, and all. That is what we cover. Okay, that is what a platform engineer do, and we will build the platforms like environments, and then we will support the development, release process, scalability. I mean, scalability here is nothing but high availability. Make sure that all the environments are up and running all the time without any impacting any customers. So we will maintain the operation side, and we will take care of the development side as well. So that is what a platform engineer do. He will maintain everything. There is a concept called configuration management engineer. This particular guy, configuration management engineer, will work on infrastructure, provisioned infrastructure. Already infrastructure is provisioned. On top of it, we have to do some things like if you want to do the deployments, configuration management engineer can use Ansible or Puppet or Chef or any other tools like Blade Logic and all. You can use that and deploy the applications or maintain the applications, or you will prepare the infrastructure for ready to deploy. Means it is like it is not like you buy the laptop and keep it ready. to run an application, you need, let's say if you want to run a Java application, you need to run Java. You need to create those dependencies. You need to have SSL certificates to make your application secure. All these things should be managed by someone. Okay, that someone is nothing but configuration management engineer. Let's say there are two people, me and the other guy, maybe Suresh. So I'm the one who will provision laptop. Means I'll buy the laptop and I'll give it to this guy, configuration management engineer named Suresh, and that guy will take that and he'll do the setup. He will boot the process. He will booting also we will only do as a infrastructure engineer. He will take that on top of the available OS. He will create a Java. He will install Java. He will install dependencies. He will maintain that SSL certificates and all. Okay, so it is not like very limited role, but again, configuration management is a separate concept. So we'll manage those configuration management. Java versions. You see, Java. If you want to upgrade Java version, that is a big task in an organization. Developers will not accept so easily until unless you provide proper justification that there is some bug or some vulnerability in the existing version, so we have to upgrade. So it is a big task. Configuration management engineer will take care of that. So that is what configuration management engineer does. There is an operation engineer, out and out. It will be a kind of maintenance project where already existing setup is there. You just have to manage that with a high availability. If there is any issue, production issue comes into picture, you have to support that through nights, days, rotational shift. This is where operations engineer, infrastructure engineer, these guys will actually cloud engineer, site reliability engineer. All these roles will be having rotational shifts. Sometime or the other, you have to take the production support. And trust me, it is not that hard. All the regular issues, every issue will be almost similar. If there is any new issue comes into picture, if it is not available in our archival here is nothing but every company will track the issues on one particular Confluence page or any particular tool. So whenever you get an issue, you just have to take that and search it there and understand the issue. To get that level of knowledge also, you just have to practice it. Okay, so it is not that easy what I say, but again you have to practice makes it easy. Okay, first it will be hard, but once you start practicing, it will be like routine process. So operations engineer will maintain the infrastructure, will manage the production support, will manage the other environments as well, and whenever it is required. Okay, so that is where the operations engineer do. Coming to the infrastructure engineer, infrastructure engineer will be in the process of designing the architecture of a application. Means if there is any application, what sort of infrastructure does it need? He'll be in that particular role, and then he'll start implementing that. Once the architecture is finalized, he will start implementing it. Provisioning part he will be taking care. Maintenance part will be taken care by operations engineer. Provisioning part will be handled by infrastructure engineer. Okay, if there is any upgrades or if there is any new requests or new changes or new cluster provisions, all these things can be handled by infrastructure engineer. Okay, infra could be public, private, or on premises. It could be anything. So we can call them on consultatively. We can call them infrastructure engineer. So cloud engineer is this particular role is dedicatedly for cloud, public cloud, could be AWS, any cloud. It could be AWS, Azure, Alibaba, Google Cloud, anything. But then he'll be the point of contact for provisioning the infrastructure on AWS using Terraform, or not only AWS, to any cloud using Terraform or Pulumi or any cloud formation, AWS cloud formation tool which is dedicated for AWS. So he will be taking care of that cloud related positions. Okay, so SRE, like I said, he is the one. Operations engineer and SRE is very similar. So he will be taking care of the reliability of the system. He will maintain the reliability, monitor the application, infrastructure, and then applications as well, log monitoring, production support, upgrade the infrastructure, maintain the infrastructure for high availability. All these things will be handled by SRE. This role is popping up very much these days. SRE, cloud engineer, senior DevOps engineer, build engineer. So these are the main roles that I see very often. Operations engineer, I'll tell you, DevOps engineer or senior DevOps engineer, build engineer, build and release engineer or build engineer, then operations engineer, infrastructure engineer. At startup level, people are calling as infrastructure engineer, but then big giants or standard companies will call it as cloud engineer, and there is a SRE concept. So this both will go hand in hand. Okay, so then there is a system administrator who will maintain only the computer-based systems like on-premises. The IT admins that we see, right? They are also calling themselves as DevOps if they are working on some automations or provisioning the infrastructure on on-premises. They'll also be called as system administrator. Again, it is a role. Anything that deals with infrastructure, these days called as a DevOps engineer, and they are also switching the rails to change them from only infra to other areas like automations, Kubernetes, DevOps, CI/CD. Okay. So I want to talk more on DevSecOps. I will take another maybe 3 minutes or 4 minutes, and I'll leave it for 5 minutes for your questions. This is a very important role. Okay, this role, this particular DevSecOps role, DevOps you already know. Security. So why does Sec came in the middle? You can say DevOps Sec or Sec DevOps. Anything could be done, but the reason why they kept in the middle, my understanding is it's not like there is any a particular dictionary or some particular definition how it has been written. But my understanding is security will be should be checked on both development side and operations side. Okay, let's talk about development side. So once the code is developed, we have to check whether code is having the standard best practices at the organization level. You cannot write some junk code and give it into the production, and that particular application will be easily penetratable, means easily hackable. So you cannot give that code. So at the beginning level, you have to check that. So security comes from development things. So once the code is developed, we as a DevOps engineer set up some mechanisms we will have check marks, we'll have Datadog, we'll have SonarQube, we'll be having multiple tools to check the code quality, static code analysis, dynamic code analysis, and static application security testing, dynamic application security testing, SAST and DAST we call it as. You don't need to remember that. You will get it over a period of time, but then remember that there are tools that actually scan the code. Okay, it could be SonarQube. Most probably companies use SonarQube to do the static code analysis. Okay, so we will be getting a lot of things under that, like vulnerabilities, bugs, code coverage. Everything will be covered there, and we will submit a report to the SonarQube where you can see it in the dashboard. So that is first level of security. Second level of security is CI/CD security. Means we as a DevOps engineer should ensure that our entire CI/CD is being secured. Means if you host a Nexus, or if you run Nexus, if you run Jenkins, if you run SonarQube, all those tools should be secured enough. It is not open to internet. It should be secured enough. It should run under HTTPS, not HTTP. We'll talk about HTTP and HTTPS separately. But remember, HTTPS is secured. So how to secure that? You have to have SSL certificates. You have to create a Jenkins that is robust and version very latest version upgraded, which will have all the patchings done. Any vulnerabilities fixes, everything will be done. So that is where CI/CD. I mean, I just gave one example of Jenkins, but we have to maintain for all other tools, like including the Jira as well. Okay, Jira is a software that we run it on the server again. It is not that we get it from the internet. We get it, but we have, when you go for enterprise edition, they will give a software. We have to run it and give license. Okay, so there are on the CI/CD part, we will take care of that. We have ZAP security, ZAP security tool, OZAP tools. We have multiple tools to scan the application. So earlier I said code scanning. Then once the code scanning is done, we'll create a binary or application. That application also need to be scanned. So for that, we will be doing WhatsApp, or we have multiple other tools to do that. Checkmarks also will do that. Will do the testing of the application creator, artifact creator. Okay, so there are these tools that is going to help you to scan the artifact or executable file that we get. That is the another testing. There is one more testing where we scan the machines itself, means wherever we run Jenkins, Nexus, Docker applications we run on the environment side, all those infrastructure security we call it as. Before talking that, I'll talk about a little bit of Docker image security. So we will scan the Docker images as well, Docker images, where that particular image is highly secured and had a robust system, reliability system. So we will also check that. We use sneak tool, or we can use uh, there is Qualys. Okay, Qualys. There are a lot of open source tools. We can take any one tool and do the scanning for sneak and all. Okay, so we that is also one security. Docker image scanning is one security. Then infrastructure security comes into picture, where we scan the virtual machines, that everything that involves for us as a DevOps engineer. Any platform will have these virtual machines, Dockers, pods, and all. So we have to ensure that infrastructure is highly secure, and we have multiple tools to scan that as well and do the patch management. Okay, once the vulnerabilities are identified, the tool will recommend the solution as well. We have to just implement that. Okay, it could be file system vulnerability, it could be the package vulnerability, or it could be any other vulnerability. It is going to identify. Qualys tool, sneak tool, those tools will identify and provide the solution. They will suggest the solution as well. It is our decision to whether apply it or not. So that is also one sort of security. Now there is uh, so these are few security points, and there is network security, which is again very important, where we cover the certificate management uh, for our entire. If you are serving an application, let's say if you go for any google.com or any application to the matter of fact, let's say I'll go for, let's say facebook.com. See, this is what a secured application is. Connection is secure. Okay, how does this secure connection is secure? How does you get to know? See here, certificate is valid. So we will have as SSL certificates. We will have TLS process, TLS terminations, or whatever you call it as. I'll be giving a brief idea of that during Linux sessions. We'll be so as a DevOps engineer, we will handle these certificates, TLS management. Make sure that everything is running under HTTPS, not HTTP. HTTP is local, where you see like this, and this is not secure. You see your connection to this site is not secure. Okay, so and if you go, you don't have any certificates to valid to make it valid. This is my Jenkins running in my local, and this is not secure. Sorry, I don't think this is localhost 8080. This is not secure. Okay, so to make it secure, we have to have SSL certificates, and then we have to put it in one of the folders, and our application should pick up. That there is a separate process. I'll be talking about that in upcoming sessions. Okay, so coming back to this thing. So these are a few security things. That is where DevSecOps came to picture, and it has a lot of potential regarding the packages as well. Very good packages. Fancy packages are being offered for these positions, and keep an eye open to understand what DevSecOps are. Okay, so I think these are the titles and positions that you need to understand even before going inside or you start the web's journey. I don't know how many of you know, or how many of the other courses that you have seen where these are all things covered. But again, it is very important, very important to understand what you work for, what will be your day-to-day activities. Okay, typical day-to-day activities for a DevOps engineer should be once he logs in, he'll be, if he is responsible for the CI/CD, he'll check the pipelines, or if there is any. Most probably, all the pipelines will be working fine until unless developer comes in and reports. There will be Jira ticket queue, where there are developers and multiple people raises issues, and we'll go there, see the existing issues, pick one, work on that, resolve it, again pick one. So either we have to pick it, or our scrum master or your DevOps lead will assign those. That is one thing. You will be working on infrastructure where you will be having connects with the development team, means calls with the development team, take the understandings, get the requirements. If there is any existing infrastructure to be upgraded, you have to take a note of it and apply it on the lower environments first, and then go for a staging and production. That is how we follow. That is one scenario. There is one more role, like operations engineer, where we work on rotational shift. Our primary role would be maintaining the production and staging environments. We will get a mainly production environments. We'll get notifications. We have to respond it, acknowledge it, and start debugging the issue. Try to resolve it at the earliest. If it is not the DevOps issue, which involves infrastructure or nothing, we don't have any role to play, then we have to notify the applications team, and those guys will have a call with us, ask some details. We have to provide them. Based on that, they will provide the solution. That is also one day-to-day activity as a production support engineer. Infrastructure engineer, like I said, we will get all those. Configuration management engineer, once the infrastructure is provisioned, he will get the requirements, what all things that he needs to be installed before deploying an application, or if he is handling the deployment as well, he'll be taking care of that as well. Automation engineer also is there, where he will be dedicatedly working for automations, where if there is any manual task identified, he will automate that. So using Python, Bash, or whatever language he wants, he will do that. He'll take that and he will do it. So these are few day-to-day activities that I can say. I can talk about these things more, but when and where required, like when I cover this on daily basis, I'll be giving line by line or piece by piece, so that you can put it in the resume. So everything that we do, we'll keep the same things in the resume, and we will be good enough to respond. Or if there is any questions asked, you can easily respond back with those answers if you have already done that. Okay, so that's the session. I'll give 2 or 3 minutes of your time. Let me know if you have any questions. I'm happy to answer. Thanks for attending the session. Open to you. Any questions, any doubts? I have already given how to attend the sessions. Again, I'll be sharing it in groups across. Let me know if you have any other questions you have, or else we can wind up. Any questions, any doubts, or any questions related to the course? If you have, you can ask it. Yeah, Hikshit. Go ahead.
Every day the timings will be the same, 9 to 10.
I am working on the timings. I have kept a poll. I think you have joined only today, so there are. This is my second session. Even before first session, I have kept a poll where people more often ask for 9 p.m. But again, I'll put one more poll. I'll take the suggestions and work on the timings as well. 9 p.m. should be like people should have dinner and sit, uh, like uh, like good timings to hear, or it should be morning. Again, mornings is like if there is any officers, again I have to rush back. So I took evenings as a primary timings. But again, I'm not limiting morning also. I'll try to work on 7 to 8 a.m. But then suggested timings by most of the people are 9 p.m. and 6 p.m., 6 or 7 p.m. Since majority took 9 p.m., so I have scheduled. I'll work on that again if you have any constraints on that, or if there are multiple people who has constraint, I'll try to.
No, that's fine. I just want to know whether it's the same timing.
Yeah, it will be same timing. I'll be posting couple more sessions in the Google Meet, but we do have our own Dell DevOps application. If you are using Android, you can go here Google Play Store and search for Drill DevOps. You'll be having an application there. If you are using iOS, you can download Class Plus. I'll be sharing it in the group if you want. You can also use that. Try to search with one of the. Let me show you for builder apps. See, this is how to you can have this application. You can have this application where you can actually see this course type of courses there. Okay, so not this builder apps. We have our own website. You can go to courses and register for a course, open course right now. Mine is batch-02. This is my batch-02. You can go for batch-02. Batch-1 is already done. So you can go
I
for
think
batch-2.
you're not sharing.
Oh, sorry. My bad. Let me share. I hope it's visible.
Yeah.
So this is the app, Drill DevOps app in the Play Store. If you are going with Apple or iOS, in the App Store, you can search with Class Plus, and there is a separate code. I'll be sharing it offline or in the group. You can follow the process. And if you go for DevOps.com, you'll be having this page. You can go for courses. You can attend from laptop as well. Again, you have a feasibility of or joining from the mobile as well. But again, you can also join from here as well. Okay, you have to register to the application, but not now. I'll give a couple more demo sessions, another 2 or 3 demo sessions, and then I'll go for private. Till then, I'll be giving it as a fee, and all these sessions are recorded, and I'll give detailed sessions as well. Recording sessions with all the PPTs, and I'll convert these into PDFs and provide it. Going forward, if there is any commands, process related steps or not, I'll be providing as a notes. Okay. So, any other questions you have, or anyone? Any questions? Any doubts?
Is this a shared folder, Kalyan? I mean, how much validity will be having to that courses or the recordings?
So I'll tell you the timings. I am thinking of to give for 6 months. Again, if there is any specific request from everyone, I can extend for another 2 or 3 months. I'll work on it. I have tied up with these ClassPass guys, so I have to talk to them, and I have to get some extra approvals to provide that extra timings. I have to talk to them first. Okay, but for now, it's actually 6 months as per the agreement. But then I can work on the expanding the duration as well.
Okay, fine. Thanks.
Any questions? Any other doubts? If not, we can wind up the session. Thanks all for joining. I will meet you tomorrow.
Yep. Thank you.